Welcome, everybody. My name is Todd Terrazas, and I'm the executive director of a nonprofit called AILA. We're obviously based in Los Angeles, and typically we would host a number of different events throughout the year, engaging our community about how AI and new technologies are impacting society. Given the circumstances, we've been doing a lot of different virtual events, and this is our first debate. And so I'm really excited to see, how Megan Peters and Steven Schkolne will debate about are machines conscious. And so today we're going to be using Slido for if you have any questions. So expect them to give a 10-minute talk each. They'll go into their debate and then we'll have some question and answer. But Dylan Morris is our host and he will be moderating the session. And so without further ado, Dylan, it's your show.
Thanks, Todd. And hi, everyone. Thanks for joining us tonight. Looking forward to a really lively debate here. Excited to have the opportunity to moderate a debate around such a fascinating and loaded question as are machines conscious? I personally might understand one of those three words. So I'm looking forward to hearing how our panelists describe their positions. So without further ado, let's get into it. Arguing in the affirmative, we will have Steven Schkolne. Steven is a consultant and author who's been working at the interface of humans and machines since receiving his PhD at Caltech in computer science. I was able to see his PhD thesis and it was fascinating virtual reality, pushing that envelope on the digital, and he's been doing that as an author ever since. So I'll be excited to hear his position. And then arguing in the negative, we have Megan Peters. Megan is an assistant professor of cognitive science at UC Irvine, where her research focuses on neuroscience, machine learning, and computational modeling to understand human consciousness in terms of its neural underpinnings. So without further ado, Steven, you have the floor.
Excellent. Let's see if I can share my screen. Can everyone see my screen? Should say machines are conscious. Good. Okay, cool. So, yeah, I'm taking the position in the positive that machines are conscious. In order to defend that position, I'm going to break down a little bit what I mean by machines are conscious. So by machines, Dylan, I'm going to make it pretty simple. I'm just going to say digital computers. And that's really just in the field of machine consciousness, the discussion of machine consciousness, that's what people mean. And for consciousness, I'm going to do a similar thing. I'm going to say the properties of consciousness. Now, I don't necessarily think it's one thing. There are a lot of different things that go into consciousness. And so I'm kind of looking to the outside world to explain what those are. So consciousness, actually, there are a lot of things that kind of fit into consciousness. I'm going to restrict it somewhat into this little box in the center of my screen talking about the consciousness of machines. So we have spiritual properties. So people will talk about things like awareness of God, Christ consciousness, Buddha consciousness, things like that. I'm not going to defend the supernatural, but not only in religious contexts, in philosophical contexts, you have things like, some kind of indivisible essence, the infinite regress of an I behind the I, the ego behind the ego. I'm not going to defend those positions. On the bottom, we have implementation-specific properties. So those are things like, being implemented with quantum physics, quantum consciousness, say the existence of a certain EEG signal in the human brain, or like requiring neural nets or statistical inference. In order for me to maintain my argument, we sort of have to look at it in an implementation independent way. And on the left and right, we have these things like free will and emotion, which often get bundled into discussions of consciousness, but people, in terms of like academics and authors who write about it, tend to think of those as separate subjects. I'm going to focus on the sort of more classic consciousness things. And my view on consciousness is basically like the philosopher Daniel Dennett, is it's a bag of tricks. So it's a bunch of different things, or a bunch of different properties. If you look at the history of people writing on consciousness, I'm basically going to take, and here are 10 such things that are used to describe consciousness, from things like the sort of dictionary definition, like awareness and self-awareness. And basically all these things, I'm going to argue, are demonstrated by machines. So, awareness is machines using sensors to react to their environment. That's seen even in very basic computers. Self-awareness, we see in operating systems that have a persistent model of themselves and can, that changes over time and guides their action. The medical definition, sleep-wake cycle. So machines, I mean, I think everyone's had their laptop go to sleep on them, but and they do have this property of having things that are active or things that happen when active processing is not going on in the background, like underlying hardware. A lot of people look at symbolic language as a criteria for consciousness. I mean, that's kind of an older one, but machines, I mean, the essence of a machine is rich symbolic language. And machines not only use it to sort of govern their internal operations, that's also what machines use to tell us about their awareness, to tell us about what's going on inside of them, and to speak with other machines and to interact with humans. Theory of mind comes up a lot in conversations of consciousness. Theory of mind is kind of the notion that we have a mental model of our own mind and of others' minds, and consciousness is using such mental models, having such a mental model, and utilizing it. Of course, if you look at machines, they have models of their own mind. They also model the minds of other machines. If you look at a cluster and there's one computer kind of managing the other computers, this simply wouldn't be possible if it didn't have an idea of what was going on inside of those machines. And beyond machines being able to model the minds, you know, maybe it's a stretch to call that a mind of a machine, but they can certainly model the minds of humans, where we see with things like recommendation engines, being able to monitor your preferences, as well as computer vision programs that can detect your mood and emotions. You could even argue that machines have a much more sophisticated model of human minds than humans are capable of in some of the feats that they can perform. And moving towards some more contemporary philosophy, we have ideas like access consciousness or conscious access, which is the ability to access the mind. It's a bit of a circular definition. There are a lot of definitions of consciousness that have conscious in the sort of description. But basically, if you focus on the sort of access part, that's actually fundamental to the von Neumann model of machines. And not only do they deal with data, but they can also access their inner workings. And here you could also say that, you know, in terms of the ability to access and know one's mind, aside from various like barriers that are put up for security purposes, machines have a much more potential to know everything that's going on inside them than humans do. In the top right of the slide, we kind of get into a lot of the more contemporary philosophy. And this is sort of a trend in philosophy that started in the 70s and kind of got really going in the 90s. You might have heard of things like the hard problem of consciousness. And basically what started to happen is people kind of came up with new criteria for consciousness, I think in part motivated by machines having done so many of the sort of older criteria, which are on the left half of the slide. And here we things like subjectivity and experience. And I find it hard to argue that machines don't have subjectivity, just because things happen to machines, like a tree can fall in the forest, a machine can be the only one that hears it. Machines have experience. You know, things happen to machines, they process it, they record it, it becomes part of their memory, can guide future activity. And then there's this phrase, you know, what is it like to be something? And that's from Nagel, and his argument is like, there's something it's like to be a human, and I can imagine what it's like to be a bat. It's hard to break down what exactly is meant by this phrase, but I see it as being an ability to have a sort of relatability between a mind, sort of like my mind is, say, more similar to like, you know, Dylan's mind than like a bat's mind. And similarly, we see a similar likeness within how machines function, like one iPhone is more similar to another iPhone than it is to my mail server. In the bottom right here, we start to have some neuroscience terms that have come up in the last 10 or 20 years. So one of them is this concept of phi, which we see in this integrated information theory. And that's a quantitative, like a number that you can use to measure consciousness. Phi is above zero, something conscious. Many even very basic circuits have non-zero phi. Even the authors admit that machines have a phi value. What's surprising, what the authors don't like to admit, is that you can build a machine with arbitrarily large phi. So I'm not sure how solid this measure is, but certainly machines attain it. What I think are a little more convincing theories coming out of neuroscience that actually do have predictive power in explaining how the brain operates is global workspace theory and attention schema theory. So global workspace talks about the brain having a central repository where perceptual information is shared for other parts of the brain to access it. And you know, if you know much about computers, like since the days of the ENIAC, it's been key to have these kinds of global workspaces, whether it's registers, RAM, disk. If you look at how the Unix operating system works, there's so many things configured in the files that the OS uses to sort of coordinate the behavior of the machine. Similarly, if we look at the attention schema theory, which talks about those the authors of that theory say that consciousness is the ability to have a model, like a schema of what you're paying attention to, and have that change over time, sort of have the ability to access that and use that to guide decisions and sort of things of that nature, which is what we see happening in a task scheduler. Like at a low level, we see that happening in any contemporary operating system. And on a sort of more anthropomorphic level, we see it happening with autonomous vehicles that use a variety of sensors. They even turn on and off different sensors so they can pay attention to different things in order to fulfill their objectives. So, to prove my claim, machines are consciousness, do we need to prove all of these or one of them? I think it's a pretty good representation of the things that people mean by consciousness. And for each one, when we look at it, we see that machines demonstrate it, and so it's kind of curious that all these things are true when people came up with these things looking at people and how they work, which raises the question, is there something magic happening? Is there something weird going on? And what I see is that there's nothing magic, there's nothing that special. It's just that in order to be smart, the way that machines are, the way your smartphone is smart, in order to do smart things, all the observable properties of consciousness that we've taken from the human mind are needed. So instead of something mystical, these properties arose out of necessity, in part because we were made machines to do the kinds of things that we like to do and to interface with us and to work with us. And so then this raises the question, why do so many people think machines aren't conscious? Why is it an uncommon notion? Why is it not our just base for our society to think of a machine as consciousness? And I think it's due to this thing that I call the carousel of consciousness, which is kind of like, as I talk to people of consciousness, when I started thinking about it, my brain really spun around. It's like, oh, maybe consciousness is this, maybe it's this, maybe it's this, and maybe it's this. And when I talk to people about this subject, what I find is they're like, oh, this is what consciousness is. And I start to explain how a machine demonstrates it. And they hop to another and hop to another, sometimes so quickly that I can't even catch up and explain how machines demonstrate the various ones. So I started to wonder what propels this carousel? What makes the carousel spin? And here are sort of 4 reasons. And you might find the carousel yourself going right now. And I hope it is to a good extent as you start to think about what consciousness might be. But what propels it? So we have a neo-vitalism. So vitalism is this idea from the 19th century that life can't be explained just due to physics and chemistry. There must be some magic, mysterious thing other than physics and chemistry to make things alive. And so I see consciousness, these people who think, oh, consciousness is not just these things that we can see and explain, as having a similar vitalism. They think, oh, there must be something to my brain other than what we can measure. There must be something magic there. And I think that's what makes us keep pushing consciousness further away. Like, oh, there must, and not sort of facing the facts that machines demonstrate it. Another proponent is this thing, human exceptionalism. We like to think of ourselves as special. And so we're hunting for things to differentiate ourselves. We don't want to admit that there's no magic property that we have, and consciousness is kind of the repository of that. If you look at ethics, there are huge ethical implications for us to put this with this label consciousness. For example, we use it to decide whether or not to remove life support, or whether to, the line for abortion. All these hot topics, for some reason it factors into there. So we're unwilling to admit machines have that because it just screws our ethics up in ways that we can't reconcile. And the other one is the future of AI. And maybe not entirely the people in this audience, but certainly amongst the more general society, people really want to believe that, at some point, some switch is going to get flipped and machines will just be like us. And this is this magic thing that AI is working towards, which is consciousness, and machines can't possibly have it. That's what kind of makes you not want to face the facts that I presented, which are, to the extent that consciousness has been characterized, digital computers have the properties of consciousness, and that's the essence of my argument today.
Thanks, Steven. That was quite a lot of material to digest, but it was very well thought out and well presented. I think you took about 15 minutes, just shy. So Megan,
Yeah, I took 12, but Megan can
12.
have.
Oh, so your timing, great. So Megan, you have somewhere between 12 and 15 minutes to present your opening statements.
Great, awesome. Well, it's really fun to be here, and thanks to Steven and Dylan, and also for Todd for hosting this. This is really fun. So I'm going to go ahead and share my screen here, and then we can get going. Can you guys see my slides? Yes? Okay, cool. Okay, so we didn't actually plan the parallelism in our intro slides, but it's great that Steven's was machines are conscious, and I'm saying that they're not in like exactly the same phrasing. So I'm going to argue that machines are not conscious, and here I also have the same definition of machines that Steven has, which is that they're digital computers. And so I'm referring to machines as kind of the artificial agents that we have built, computers or the software that runs on them. So, and I'm going to argue this from the scientific perspective. So I want to start, like Steven did actually, with taxonomy, and I swear we didn't prepare these in parallel with each other, but that's how it works out. So I want to start with taxonomy too, and there were kind of three categories that I think, when we think about consciousness from a general linguistic standpoint, the types of things that we think about generally fall into these three categories. And so those are sleep, coma, wakefulness. Those are the subjective experiences, the phenomenology, the something that it is likeness, the ineffable, intrinsic, internal experiences that you have of the world. This is, if you're familiar with the philosophy of science arguments, the redness of red or the ouchiness of pain, the something that it is like, a la Dave Chalmers and the hard problem, and so on. And then the third one would be the self-referential type of consciousness, the reflective consciousness, the self-awareness or meta-awareness. So this is like the fact that you know that you are sitting in front of a computer right now, you know that you have an identity, you know that you are aware, and you know that you have subjective experiences like pain and red and so on. So of these three kind of broad categories that I think that the word consciousness falls into in our everyday parlance, it seems to me that the one that we are most concerned about when we talk about ethics, when we talk about everyday language and so on is the second one, the qualia, the subjective experiences, the internal, ineffable, intrinsic experiences that we have of the world, the fact that pain hurts, the fact that red looks like red and not like green. And so some of these other things are things that we can imagine building into artificial agents, but that don't necessitate endowing those artificial agents with consciousness or what we think of as consciousness. And so, and these all, of course, relate to each other as well. So sleep and coma and wakefulness provide a necessary substrate for the other two in a lot of ways. It's not a sufficient substrate. So just because you are awake and not in a coma doesn't mean that you have an internal experience of the world, an internal subjective experience. And self-awareness is also something that does not necessitate internal or qualitative experience. You could imagine building an agent that has something like self-referential capacity without any sort of internal experience at all. So you can build a robot that knows it has something stored in its memory, that it has traveled a certain path, that it has 4 wheels or 6 wheels, that its identity is Wall-E, for example, but that doesn't mean that it has something that we think of as consciousness. And so I think that qualia, however you want to pronounce it, is the closest thing that we have in our everyday language to what we think of as consciousness. And for the purpose of discussing morality, and when we need to start worrying about whether we should pay attention to whether we're allowed to kick our robot helpers or not, this is also the one that we kind of care about. So notice that I also purposefully avoided in this list discussing what I call functions associated with consciousness. And so this is also some language that Yoshua Bengio has used as well. And so these are things like agency, intrinsic motivation, reasoning, working memory, flexibility, generalization, one-shot learning, symbolic manipulation. All of these things are functions typically associated with consciousness, at least in us. But I think that it's a mistake to conflate them or confuse them with consciousness itself, which I think is much closer mapped onto the qualitative experiences that we have. So it's this one that I want to focus on, and that functions associated with consciousness are great in that they can give us a handle on the generative and computational underpinnings and generative structure that leads to qualitative experiences. But these functions associated with consciousness, like symbolic manipulation, working memory, generalization, that kind of thing, they are not consciousness itself. Okay, so even if we narrow our definition down to that phenomenology, that inner experience, and not sleep versus wakefulness, and not self-awareness or self-reference, there's still like this huge heterogeneous space of research approaches. And some of these are ones that Steven also put up on his slides. So just to name a few of the dominant or semi-dominant theories, research approaches right now in consciousness, we heard about integrated information theory. But then there's also a whole host of other ones. So there's these first order or local recurrency theories. There's the global neuronal workspace theory. There's attention schema theory. There's higher order theories, which have one foot in philosophy and one foot in science. And there are tons more that I'm not even putting up on these slides. And in fact, there's actually so many of these competing and potentially incompatible theories that there's actually a whole program run by the Templeton World Charity Foundation that's like the Thunderdome of consciousness theories, where they put two theories in the ring and make them fight it out. Try to sort out which one is right. So we don't know which one of these is right yet. We are just very much at the early stages of consciousness research. And so then you might ask, of course, well, we've got amazing AI. We've got amazing technological progress. We've got amazing ability to record from the brain. Why don't we know which one of these is right yet? And one of the reasons that we can't agree on the generative processes that actually give rise to qualitative experience is that we have really impoverished ways of measuring consciousness. And so again, this is a list that's kind of overlapping with what Steven showed. But I'm going to try to argue that what each of these measures that we have for consciousness now, that these are all impoverished, that they're not good enough for us to be able to ascribe consciousness or qualitative internal experience to any artificial agent. So of course, gold standard Turing test, right? If anything, though, the Turing test doesn't measure internal experience. It measures compute speed or capacity, maybe intelligence, but certainly not consciousness. So for those of you with a philosophy of mind background, you might agree that Searle's Chinese room argument is really very appropriate here, that the capacity to do symbolic manipulation, to match inputs with outputs in an apparently meaningful capacity to an external observer is not the same thing as having internal comprehension, and certainly not internal phenomenology. So next, a gold standard in science would be the introspective or subjective first-person reports. So like I ask you, are you conscious? And you say yes. And so the problem, of course, with these that keeps getting brought up over and over again in science is that they are neither necessary nor sufficient indicators for the presence of internal experience or phenomenology. So I ask Siri, are you aware? And Siri says yes. But that doesn't necessarily, to me, say that there is anything going on inside Siri's head that is mapping onto subjective experience at all. And on the flip side, you can also see that these are neither necessary nor sufficient indicators, because there's this thing called locked-in syndrome, where you have a person who is actually there on the inside. They're actually experiencing themselves. They have subjective phenomenology, but when you ask them, are you there? They don't answer. And so this is not a great way for us to be able to tell whether an agent is conscious or not. And actually the point here that I want to make is that there's a whole area of research springing up now called no report paradigms, which is trying to get away from some of these subjective reports. So what about some of the objective measures like integrated information or the neural correlates of consciousness, that we have the ability to actually measure what complexity measures, what information theoretic mathematical approaches, and what neural patterns of activity are typically correlated with consciousness. And the problem here too is that we don't know that these uniquely map onto consciousness. We can see that more complexity, more phi, more IIT's phi may map onto consciousness, but it may not be a unique mapping. It's the same for neural patterns. We have patterns of activity that go with you being conscious or you being not conscious, but we don't know if that's a unique mapping. There's this whole idea of multiple realizability in philosophy of mind and philosophy of science. And so there might be other ways that these map onto consciousness or don't map onto consciousness in artificial agents. Okay, and also the neural correlates of consciousness has a whole problem that has to do with the paradigmatic confounds that have been used to evaluate and reveal these neural correlates of consciousness in previous science, and we can get into that later if you want to hear how bad the science is so far. So just a couple other things. Causal and generative modeling approaches actually seem to me to be a really great way to go. So we take all of this causality and mathematical approach and we pair it with the generative modeling structure that folks like Lisa Meraki at UPenn, who is a philosopher of mind and philosopher of consciousness and cognitive science, has been developing. And these are a great way to move forward, but they are still very much in development. So we're just not there yet when it comes to consciousness. And then of course, there's the functions associated with consciousness, the symbolic manipulation, the ability to have, agency, the ability to generalize, the ability or to demonstrate, appear to demonstrate agency, the ability to do one-shot learning. So I feel like a broken record here, but none of these is a necessary or sufficient indicator for consciousness in terms of phenomenology. These are functions associated with consciousness in us, but that doesn't mean that they indicate consciousness necessarily in other things. And so even if you like some of these and you think that some of these are really good indicators of consciousness, AI still fails most of these. It doesn't do a great job. At the very least, you might get asking Siri, are you conscious? And Siri says yes, but that's about as far as they get. They still break an awful lot in terms of their ability to pass even these poor or invalid benchmarks. So before I wrap up, I want to take a moment to say this seems like a super pessimistic approach, especially from someone who actually studies consciousness scientifically. And yes, I am arguing that we don't yet know enough really about consciousness to scientifically determine whether it exists in other beings. But I think there's evidence that it doesn't yet exist in artificial agents. However, by pairing ongoing and recursive theoretical and empirical work, I think that there's a lot of ways that we can move forward in trying to address whether it will eventually arise or that we will eventually build it into artificial agents. So we compare specific experimental approaches that will identify and characterize the functions that are uniquely associated with consciousness and then go assess whether artificial agents have those. We can improve and expand our causal and generative modeling approaches. We can improve our experimental hygiene. And this is what those adversarial collaborations are doing to try to arbitrate theoretical predictions, come up with predictions that are incompatible with one or more theories, and then go and test them. And so all of these, I think, speak to the need to move away from studying the neural or computational correlates of consciousness or functions associated with consciousness to starting to unravel and peel that onion to get at the generative structure and the generative computations that give rise to phenomenology and subjective experience. So in conclusion, I think there is no evidence that convincingly supports the presence of something related to consciousness in terms of the subjective phenomenology in any of our current artificial agents. So that's it. Thanks.
Great, thanks, Megan. That was very helpful and super enlightening. And oh, your desktop matches my background. Wonderful. So we're starting to see a bunch of great questions from the audience. But before we go there, I think in the spirit of debate, I'd like to give each of the speakers a chance to respond to the other's opening. So we'll continue in the order in which we began. And Steven, why don't you take no more than 5 minutes to hit on any of the key points or issues that Megan raised. And then that should kick us off into a debate where, Megan, you can respond both to Steven's points now and to his initial points. And then after that, we'll start opening it up with more questions.
Sounds good. Thanks, Dylan. And thanks, Megan, for a great opening argument. I'm actually kind of tickled that we're at least close enough to have a conversation here, given how crazy the subject can be. Just to hit on a few of your points. So talking about qualia, qualia for me lives at least half in a supernatural category. It's kind of like no one quite knows what it is. No one quite knows what it looks like. What people know is they tend to feel something. One of the things about qualia is it's a lot like solipsism, the Greek old philosophical idea, or the matrix philosophy that, we're brains in a vat and no one else exists. It's actually not possible for me to say that Dylan has qualia, whatever they are, and similarly, it's as possible to say that someone else has qualia as a machine. In order to assess these things, we actually can look at the brain though, and we can see a neural scan similar behavior in, say, Dylan's mind and someone else in my mind, and sort of conclude that the same thing must be going on. So I feel like to the extent that we can attack quality, we have to look at the processes that underlie it. And you listed out a ton of them. And when people get into the brass tacks of how those work, they surprisingly tend to mimic kind of basic parts of computer architecture. For example, like the global workspace theory being a lot like RAM in a machine, or registers for the CPU. As for the Siri point, I think, self-reporting, it was what I actually took it off my slide, but it's a criteria for, like, do you say you're conscious? I find it really curious that people tend to look at human language as the metric for that. It's like, oh, did you tell me in English that you're conscious? And of course we have these robots that, like Siri, that can pass, or they're not robots, software that can pass Turing tests because they self-report in a way. My perspective on that though is it's not really an authentic self-reporting when Siri tells us in English, hey, I'm conscious. But if we want to see the kind of, cogito ergo sum of a machine, we can see a much more authentic self-reporting of its mental operation within the OS. And I think this kind of hits upon, where you said AI fails. Like a lot of my position on consciousness in terms of my slide and like the things we see that match the sort of, that demonstrate consciousness, surprisingly, a lot of them don't happen in AI. Like having a shared works with sensors, like integrating a bunch of different sensors and making decisions. It doesn't use at least contemporary AI, right? Maybe older AI that people don't think of as AI. But a lot of the core like mental operations of the machine that are similar to the human predate, the current generation of AI. I'd also like to highlight that, and this is sort of my experience reading a lot of the neuroscience literature. I agree with you with all, like, there are just so many of these theories. I was, reading some of the literature. It's kind of like, I was reading a book, I won't mention the book, but it kept on saying consciousness is this, consciousness is that. And by the end of this book, I was like, oh my God, like every single thing the human brain does is in this like consciousness category. Like, is it anything but what the human brain does? And for me, that's another sign that a lot of people are just looking for some kind of human exceptionalism. Like, and to me, that's just adding more horses to the carousel. So I think people are hunting for more horses to add to the carousel. And I can't debate, the horses that we'll have in 10 years if people decide to, come up with new properties they decide are consciousness. So I can't really predict what will happen as new horses get added, but I can just note that historically, every single horse that's been added to the carousel, you look and it's like, oh yeah, machines do it. Sometimes have been doing it for many years. So that's my official rebuttal. I'll pass the mic back to you, Dylan, to pass it on to Megan. Yeah.
No, that's fine. Megan, I'm sure you'll want to respond there. And then if you also want to go back to some of the points Steven made in his initial argument, please feel free to approach those as you see fit.
Great. So I actually, I do agree with you that we shouldn't be adding more horses to the carousel. We shouldn't be adding more like things that are additional. We shouldn't keep moving the goalposts, so to speak, about like what is the thing that an AI or that a machine needs to achieve in order for us to believe or endow it with consciousness from our perspective. But I don't necessarily agree with your statement that qualia is supernatural and that it's this kind of like solipsism, brains in vats kind of approach. That yes, of course, like there's the old kind of trope, like I can't prove that you're conscious and you can't prove that I'm conscious and we're all just philosophical zombies. But I think that there still is something kind of meaningful and true to saying that we all, I hope, everybody who is here knows what pain feels like and knows that it is not just a collection of symbols or a collection of brain states, that there is something that it is like to be in pain. And so I don't agree with Dennett that qualia is an illusion either. I think that it is real. But I also think that we don't necessarily know how to grasp it with science yet. That doesn't mean that it's magic. We just don't know how to measure it yet. We don't know how it is generated yet. That doesn't mean that we could not get there, or that it is logically impossible for us to get there. Maybe us as humans were too stupid to get there. That's a completely different argument. But that doesn't mean that it is impossible to describe the generative process that gives rise to subjective experience with science for some agent or being somewhere. So I don't think that this is really adding horses to the carousel, so to speak. I think that I've only got like one horse on the carousel here, which is that there is something that it's like, that there is this internal experience that we have, and that some of the other things that you pushed out of your box, I think that there were, like emotion was one that you pushed out of your box, and you said that this shouldn't be part of the equation. And so this is, in one way, it's a little bit like cheating to say, oh, well, emotion doesn't count as a horse that we should have on the carousel because machines don't have emotions, and so therefore that doesn't count. But I also think that emotion gets rolled in with this qualitative experience. And so it's not a separate horse on this carousel, it's part of the same horse, to push the analogy perhaps to the point of breaking. That the brain state of having, you know, upregulated amygdala reactivity. So the amygdala is the fear center of your brain. It lights up and it turns on when you're scared, and it, like, you know, turns off when you're not scared, basically, is like the cartoon version. And so there's a lot of work being done, especially by folks like Joe Ledoux right now, where just because your amygdala turned on doesn't mean you're scared. And this is potentially that, like, the experience of fear and the brain state, or the, you know, computational state. If I built in silico, you know, simulation of a rat, and it had a fear center, and like that fear little circuit turned on, and then the robot agent scurried away from something, that doesn't mean that the robot experiences fear. And so this disconnect between the brain state or the computational state and the experience of it is something that I think is really important for us to pay attention to. And it's something that may be an argument why a lot of animal research on pharmacological interventions for anxiety and fear and so on fails, because we do this on the rat, and we see, like, if I give the rat this drug, then the amygdala reactivity goes down and the rat stops freezing. But then we try to translate it into the human, and like the amygdala reactivity goes down, and the person is more engaged with their environment, and they still feel anxious. Like the feeling didn't go away. So that's the horse that I want to have on the carousel, is that one. And that's the one that I think we still don't have any convincing evidence that exists in machines. You could maybe argue that it also doesn't exist in me or you either, but I'll take that over saying that we have convincing evidence that machines have something that it's like to be them. I think that's probably what I need to say here. There's a couple other things that we can get into about, like, simulation of other people's minds and theory of mind and stuff like that. But maybe I'll save that for a little bit later, because I think that my time's up.
Yeah, no, that was a great response. And I could see Steven chomping to respond. I think the question might have shifted from are machines conscious to are we conscious, which is okay. But Steven, how do you feel about it when it comes to defining phenomenology in materialist terms?
Yeah, I think, you know, Megan, I was just writing down, you know, generative process that explains subjective experience. You said that there is, you know, no such process that explains subjective experience. And I see there's plenty for humans, there's plenty of data that shows how subjective experiences are formed. It's called, you know, we have like visual centers, auditory centers, things like that. Information's taken in. At some point, it's kind of, you know, broadcast across the brain, sometimes stored in memory. And then other parts of the brain can then access that information. If you just look at like the information dynamics of what's happening, and I won't say much more because I'll probably be wrong in a way that you'll correct me. But you know, that's what I see as this kind of process that makes for a subjective experience. And you see the exact same process in machines. And so for me, I'm not going to sort of say humans aren't aren't conscious. The way I look at it, I'm not a solipsist, right? I just think that like, yes, that's a hypothetically possible thing, theoretically possible, but it's a useless way to see the world because you can't do anything after that point, right? I feel the same way about, this idea of subjective experience. If I see similar brain patterns, we can understand how the information is kind of taken in and stored, and then part of, what drives the system forward, whether that system be human or machine, that's the mechanism. In terms of emotion, I'm happy to debate whether or not machines demonstrate emotion or free will for that matter. I've thought a lot about it. I'll just say a few words along those lines, which is, there's a whole range. Part of the difficulty of emotion or feelings is it's like 5 to 10 different things that are all under that umbrella. But we basically do see things like pain, like the lowest level, like I stubbed my toe. We see in machines, it's actually fundamental to machines. It was a development in the early 1960s of things called interrupts, which are like when something happens on the hardware level, the whole machine stops and deals with it. Like there are such low level, very powerful system-wide signals that operate in machines. There are also things that are sort of more global properties of machines. You could even like being hot or something can cause a whole bunch of different reactions in a machine to preserve itself. I don't think emotions are as well developed or as vital to the functioning of machines. Like machines are mainly deterministic, right? Similar to free will. But to say there aren't any emotions in machines is not something I'd happily argue. We could happily schedule another debate on emotion. As for the amygdala, it's like an amygdala response, you're right, is not fear. But what we do see in the core is like it becomes fear if other things change in the information state of the brain. And yes, in that experiment you cited, like certain things can distract the brain and make not something that the amygdala does not get translated into fear. But if you see, I'm confident that if we characterized other information state in the brain that was more tightly correlated with fear, that would be the information description of fear within the brain, and that's the sort of information structure of that emotion.
So can I ask, is your position then that the reason that we don't have these descriptions of things like fear on a neural representation level, for example, simply because we don't have the tools to see the representation, or because we don't understand the relationship between that representation and the conscious experience?
I was willing to answer until you said conscious experience, and then I'm just like, well, which consciousness do you mean? Like every time we use the word conscious, it's like suddenly this whole like laundry list of potential things we could be talking about just falls on us. Again, it's like the carousel. Like if we have to deal with the whole carousel, like which horse? So I'm not answering your question.
Well, remove the word consciousness and pretend you just said experience, and then see if you can answer it.
And what was the beginning part of the question? I distracted myself.
It's really about whether, let's pretend that we can record from every single neuron in the brain. We can simulate every neuron, or we can actually understand exactly every molecule, every like spike, every
Yeah.
Like if we have that level of description, that level of precision, do we have we cracked consciousness?
I won't speak to if we crack consciousness, but if we had that representation, I feel pretty confident that we would be able to know, yes, this is the representation that correlates 100% of the time with fear, and this doesn't. In particular, if I say I am scared, just the statement I am scared or I'm experiencing fear, there must be something in the brain that I use to generate that sentence. There must be something that feeds that self-reporting. And I think, if we could perfectly measure the brain, we would see the thing that feeds that self-reporting.
I agree with you there. I'm a reductionist at heart. I don't think that like there is, this soul that's different, but I don't agree that the representation, the neural representation or the implementation, the state of the brain is the same thing as the consciousness bit. Yeah.
So you don't think that information representation is the same thing as?
Correct. I don't think it's an identity.
Yeah, and I would say to that's because you have another belief in your head, which is that there's something else going on. And the existence of that belief that we tend to have as humans for a variety of social reasons is not conclusive evidence that there is something else going on.
Okay, I think that measuring a thing and understanding what it means, or like, it's a question about what you need to measure, right? So I don't believe that measuring every single state of every single neuron in the brain is going to give us an adequate and comprehensive and airtight, watertight description of what it is to be conscious, or what consciousness is and how it is generated. I think that that's a good first step, but I don't think it's sufficient. I don't think it's enough.
And I think that if we could settle on a few, like, not just treated consciousness as open-ended, like a blank check, but if we could just, you know, bind it somewhat, you know, then that information description of the brain will be perfectly adequate to explain why the brain demonstrates these things when we look at it, and also that we'll see that machines demonstrate the same things. And to date, that has been the case. Like, for all these descriptions we've been able to come up with, it's like more particular things, we break it down into components, every single one of them is demonstrated by machines. So
let me interject here then, Steven. So maybe the thing about consciousness is that it is a summation of the features that you are describing, and many of your examples are of machines that exhibit one or possibly a couple of those features. Perhaps a machine that demonstrated all of the features on the carousel might rise to Megan's definition of consciousness, but I guess that's a question for both of you.
Yeah, I would just say simply that that machine that demonstrates, yeah, is like a self-driving car, or particularly if you look in an autonomous military patrol vehicle. And the reason I pick an autonomous military patrol vehicle is it starts to demonstrate free will as well. It creates its own goals, it sets its own missions based on the environment, makes, you know, it has a whole, like, some kind of mojo to do stuff. It's not simply waiting for commands. So that sort of lumps in the free will aspect of it as well.
All right, I'm going to refrain from talking about setting of goals as you know, a recalibration of our own reward function and cost function, because that's a whole other conversation.
Okay, well, we're going to keep you out of it. Dylan, are you getting questions from the audience? I see just tons of stuff appearing.
Yeah, so let me remind the audience that there's a lot of text coming in on the chat. I don't think our speakers or I can really attend to all of those. If you have questions, please add them to the Slido. There are some great questions coming in, and speakers, why don't I address the highest voted of those now, which is a question that takes us a little away from where we've been, but I think is very relevant, which is about the social elements of consciousness. And the question about...
You muted yourself. Come back.
Oops, where did you lose me?
The question about...
Oh no, the question is about the social determinants of consciousness. So this isn't exactly where we've been so far, but let's go there since it's time to take some audience questions. This is the most upvoted question. How does that affect your understanding of and ability to discern an implementation of consciousness as it's reflected in the social milieu? Whoever wants to start.
I'll go first, if that's okay. So I have two things that I want to say about this. One is, I think it's absolutely correct to think that consciousness is something that requires or facilitates or involves or in some way does not exist completely in a vacuum of social interaction and interaction with the environment. And by social, it doesn't necessarily mean interaction with other agents. It's also just interaction with the world. I think that the brain in the vat is a very fun philosophical toy to play with when you're, you know, in your undergrad philosophy of mind class. But I don't think that in the real scientific study of consciousness and the study of consciousness in humans and in machines, that it's a useful exercise. So I think that this is a great question, that I think consciousness does require interaction with the environment, with other agents in the environment, and goal setting, as Steven was saying, and flexibly and adaptively updating your goals in response to environmental variables and changing kind of conditions. But I think that another piece of this puzzle goes back to what Steven was saying also about theory of mind being a part of consciousness and this ability to simulate other agents and thus facilitate social interaction with those agents. So I think my personal favorite theory of consciousness is the higher order, the family of higher order theories. because I think this idea of simulating other minds means that you're kind of simulating your own mind, or you have a capacity to simulate your own mind. And so this self-referential property, which grew out of a need potentially to predict what that guy over there is going to do so he doesn't come over here and kill you or eat you or whatever, that led to some of these experiences that we have, and that other experiences that other agents have, like dogs or mice or those kinds of things, to the extent that they have them. So it's not really, maybe I'm not really answering the question very concretely, but I do think that it's very important that we think of social and environmental elements when we talk about consciousness, and that interaction with the social and the other agents and with the environment is a critical piece of the puzzle. And without keeping that in the puzzle on the carousel, we're not going to get very far.
Cool, thanks. By the way, I'm super happy to be debating against someone who doesn't want to go into crazy thought experiment land. Like, I really appreciate it. I think it's keeping things focused for everyone. I'm also not going to go there. So the whole social dimension, you know, I didn't have that on my 10 things. We could add that as an 11th. It's certainly something that we see. I mean, the first computers to socialize with one another were used for like radar in the 60s. Like, we all know about computer networking. We all know that machines work together and interoperate. We also know that machines interoperate with humans all the time. And we also know that there are new generations of AI that, you know, actually will have like live chatbot companies. I'm sure there's at least one person on this chat who's you know, involved in that kind of work. I have a good friend who's done great work in the space. So yeah, if we want to add that as another criteria, like, do machines demonstrate socializing? They do. And therefore, you know, it's another part of consciousness that machines demonstrate. And, you know, again, I think it's sort of like, oh, wow, like this other thing that was brought up is, you know, machines demonstrated as well. I think, again, it kind of gets to my point that, you know, we made machines interoperate with ourselves somewhat in our image, and just by necessity, by design, we end up putting these properties in so they can do the stuff that we need them to do, that we want them to do. And socializing is just another one of those things that kind of get added. So I'm happy to add that horse to the carousel.
Can I push you on something though? Because like when we talk about the kind of socializing that artificial agents do right now, I feel like there's got to be some sort of like gradation to what counts as socializing. So like viruses, you know, running around in a petri dish, do they socialize? Or the little artificial agents in the evolutionary simulations, does that count as socialization? So like where do we draw the line for socializing in terms of using it as a benchmark, an indicator of consciousness, as opposed to just an element that we need to keep in mind when we talk about evaluating or understanding the generative process giving rise to consciousness?
Yeah, that's a really good question. And my position, just to sort of summarize it, I'm kind of a gradualist. So it's like, oh, does this machine, you know, I saw this on chat, like, you know, is an ant conscious or something like that? And, you know, is the thermostat conscious? Like my view is that, you know, thermostat has like it's like it's aware, right? Is it self-aware? Does it have a theory of mind? Like, no, it doesn't have a theory. You know, it's not using symbolic language, right? So I'm kind of a gradualist, and definitely the social criteria, there's a whole scale of that. It seems to me most people, like, instead of looking at the social aspects of consciousness, they're going to define this in an implementation specific way. They look at it and they say, well, if it does what a human does, then it counts, right? And there's some end of the scale, which is like what humans happen to do. So I don't even see it as necessarily a linear scale, right? It's more of a space, you know, some multi-dimensional space. But in terms of, you know, if we want to use the top of the scale being, you know, what humans do, that comes down to the Turing test, GPT-3, and, you know, the Turing test was supposedly passed by someone pretending to be like a, you know, mentally disabled child, like a machine pretending to be mentally disabled to like get away with it. So, you know, is a mentally disabled child not conscious? I don't know. I just think, if my general response is, if, you know, if the end of the spectrum is humans, machines have amply demonstrated it to the point that they can pretty much fool us now. The Turing test is, you know, within 5 years of being passed, I would say, or maybe it got passed this summer with GPT.
It might have been today, actually. I think there was a highly upvoted article on Hacker News that was written by GPT-3, but I don't think people realize that when they voted on it. So
it's not quite socializing though if there's no interaction, so it's not quite the Turing test bar. Yeah.
Fair.
And the Chinese room argument. And if you guys don't know what the Chinese room argument is, you guys out there in the audience, go check it out, because I think it's really relevant to the Turing test.
Well, and so the thing about the Chinese room argument, this is a Searle argument about whether the room itself should be counted to exhibit consciousness or an understanding of Chinese if, you know, all of the folks are following simple instructions, the way that, you know, the analogy is to neurons. And I think, Megan, by bringing that up, you're getting back to this notion where I think you two are still talking a little bit past each other, which is about qualia, which I think Steven refers to as in the spiritual category and not on his list of features which are sufficient to give machines a definition of consciousness. You seem, Megan, to think that it is, in fact, squarely in the middle and the meat of the question of consciousness. So I want to tease that apart a tiny bit, and this will be related to what's now the most upvoted question on the Slido, which is to your point about measurement. You know, could it be that consciousness is where we were before we had germ theory and the microscopes needed to understand the pathogens causing disease? Can you imagine an instrument or a set of instruments that could potentially get at a mechanistic understanding of experience or qualia?
I think you're right that we are talking past each other a little bit, but that Steven's list of what he believes is kind of necessary or sufficient indicators for consciousness in machines are what I would call functions associated with consciousness, but they are not, there's no identity there. They are a separate conceptual, a separate natural kind, if you will, from consciousness itself.
Yeah, and I would say that, you know, these things that are floating outside of functional, like, are supernatural until we explain what they are. And then once we explain what they are, we see machines can do them. So,
well, so that's why I'd like to probe this question of, can we imagine a way to measure what Megan means by experience or qualia, such that they might then get roped into your functionalist definition, Steven?
Let me take that just about terms of measuring consciousness. Can we measure it? I mean, there's this thing called IHE that has this magic, you know, number ability to measure it. I mean, the funny truth about IET is you can't actually conduct an experiment to measure, like the authors themselves say it's intractable to measure any system with more than 12 neurons. So it's like, yeah, it's like we finally made a ruler, but it can't be built. Like, you know, and like they almost hide, I think they almost hide behind that because their ruler can't be tested. Anyway, we don't need to go there. I don't think Megan needs to go there. But
I'll agree with you there that IIT, I think, is not, IIT version 1.0 and version 2.0 and version 3.0 all make completely different predictions about the same system also. So there's that.
Yeah, we could have a lot of fun just tearing IIT apart. We won't do that. But in terms of measurement, I think you sort of have to look in terms of this bag of tricks, which one is it that you're measuring? And one of the things IIT does is they think, you know, I mentioned the supernatural idea that there's like a fundamental unifying thing of some kind, like some indivisible essence. And that's actually core to their framework, is that there's some kind of indivisible essence. But if we look at what the brain actually does and, you know, what people talk about, it's actually a bag of tricks. It's a bunch of different things. So I think the idea that there's a single measure for consciousness just cuts straight against the reality that there's so many things that people put under the consciousness umbrella that we would have to measure them all, and then also make some kind of model as to exact the precise way that these things combine with one another that makes consciousness. And I think if we did that, we would actually have a very implementation specific description of the human brain at the end. And we would basically be saying, oh, it doesn't have a hypothalamus, therefore it's not consciousness, because in the model, the blah, blah, blah goes to the hypothalamus before going to this, and the machine doesn't have a hypothalamus, instead it goes this way. So that's what I would imagine if we tried to go after that. It wouldn't be some kind of single measure, but it would be basically an anthropomorphic, we would require an anthropomorphic definition of consciousness. So that's my implementation specific line there.
I'm not sure I agree.
But
I think that it's, I'm going to agree with you that a complete description of what you mentioned as like the hypothalamus, the circuit model, like this is kind of how consciousness is generated, whatever. I think that we can push towards building something like that without it being locked to the specifics of neurobiology. And so one of the ways to do this is by, as you said, enumerating exactly all of these functions associated with consciousness and how together they exist independent of or not independent of, you know, conscious awareness in any like agent that we think actually has consciousness like us. And I think that it is likely that, and we're already starting to do this, is that we are identifying very, very slowly cases where you can do X, whether you're conscious or not, but you cannot do Y. And Y can only occur when you are conscious. And symbolic manipulation, you know, unconscious mathematics is a thing that has been demonstrated experimentally, that you can do math unconsciously, that you can do numerosity judgments unconsciously, that you can do linguistic manipulation, that you can tell grammatical from ungrammatical sentences unconsciously, that you can detect things unconsciously if you have blind sight. You know, there are all of these things that kind of, as we design better and better experiments, we are going to kind of really sharply home in on the things that explicitly require consciousness, that do not exist without it. And those functions associated with consciousness then will give us a handle on understanding how that consciousness is generated. But until we get there, those are the measurement tools that we need. And until we get there, I think that all of the current things that we think are those functions associated with consciousness are, yes, things associated with consciousness, but not uniquely so. So that's, I think, the measurement tool that we need. And you know, the cheating answer to this particular question by Anonymous about what tools do we need in order to get to refining and solidifying a theory of consciousness. The cheating answer is that we don't know what we don't know yet. We need a paradigm shift. But I think it's true, you know, going back to like the Copernican versus the Ptolemaic, like, you know, system of the planets. Like, we can predict things very, very precisely right now, but we need a complete paradigm shift in how we're actually like understanding, again, this generative process. And I'm sorry to keep harping on that, but I think it's really important to separate the causal chain of events that gives rise to consciousness, which is this neuron fires and then this representation happens and then like this chemical goes to this place and the hypothalamus is involved somehow. I think it's really important to separate the causal structure from the generative process, which is like an understanding of how each of those causal elements actually gives rise to whatever it is, phenomenology or some other definition that we think of as consciousness. So yeah, I'm cheating by saying we don't know what we don't know yet, but I also think that's the truth.
Cool. Yeah, just in terms of the whole, there are things that are done consciously that then are later done unconsciously. So the experiments are on like chess players. So like for most people, playing chess requires, you know, and again, it's one definition of conscious access, which is this idea that, you know, certain like P3 wave and things like that happen, and there's like a, you know, global workspace stuff. But in chess masters, like these things actually happen unconsciously, and there could be unconscious priming for things that in other people would require consciousness. So it's hard for that to really be any kind of criteria. And it's basically learning, which seems to make these things unconscious or conscious. In terms of limitations, though, I think one thing, if we're going to head down this path of trying to say, okay, what does the brain do? And we're going to use this as a gold standard for this thing called consciousness, is we actually end up with a very limited, like, for example, the global workspace theory, it's like you can only have one thing in your head at once. Like, humans can only really think about one thing at once. Like, is that going to be a restriction? And if that's the case, do we look at machines and say, well, shit, a machine can multitask? Like, machines they can have multiple global workspaces. It can be partitioned, it can be shared. It's like machines can coordinate very easily. And like, where do we draw the line with virtual machines in terms of where's the machine? So I think it's actually pretty dangerous to go too close to this neuromodeling. I think if we stick really closely to brain modeling, like, we just end up getting this very limited kind of thing, and consciousness is basically anthropomorphic. Machines do a lot of things. Like, if we start to look at these various properties on my slides, like, machines can be like, for example, there's face tracking system in the UK or in China that can, closed caption TV. It's like 6 million cameras in the UK, all unified in one system that like funnels data and can track a criminal. So it's like, there are a lot of things that machines can do that the brain can't. And, you know, are we going to have some fair definition of consciousness that isn't tied to one or the other? I don't know. I don't know where this fits in, but as I was thinking of these limitations, I think it kind of makes consciousness a very curious thing if we have to exactly mimic what the brain is. In that case, I say consciousness is not a thing. It's some evolving paradigm that we're basically, like, again, my vitalism, neo-vitalism point. We're just trying to have this thing that's us that machines aren't, and like, oh yeah, machine's not conscious because it can multitask, eventually is part of that argument, which I find kind of preposterous. So.
I think that's a good point, that we shouldn't keep having this evolving definition, and that like one of the reasons that in part we're talking past each other here is that like our taxonomies of what is consciousness are different. But that doesn't mean that that arriving at a particular taxonomic definition of consciousness is not of value. In fact, I think that's actually like really important for us to do. And you brought up morality in your intro statements too, that like if we don't have a definition of consciousness that has some of these kind of moral implications with it, then we're going to end up making really awful mistakes when it comes to like in my mind, the probability that we will end up with an agent that even has my version of consciousness, you know, that even does have phenomenology, that has internal subjective experience, and not just self-referent, but that like there is something that it is like to be that robot. I do believe that is possible, but that the questions of morality and how we should like treat these agents depend on certain definitions of consciousness that I think closely map onto the one that I'm using, which is this idea that if you kick it, it hurts. That makes a lot more sense when we talk about consciousness to me than can it do symbolic manipulation or not. Whether it can do symbolic manipulation or not is not going to drive policy. It's not going to drive like, am I allowed to dismantle my Tesla? You know, those are the kinds of questions that I think are really kind of concrete and that we're really very close to needing answers to if we're not there already, as you might argue.
Yeah,
so yeah.
Can I ask you about qualia?
Sure.
Is qualia demonstrated? Is it something that is demonstrated?
Demonstrated, like scientifically?
That there is evidence. Is there evidence of it?
Evidence from what perspective?
Objective evidence.
The whole point is that it's subjective, it's ineffable, it's personal.
Right, so it's basically designed to be never discovered.
In
like,
its
for me, that's
current linguistic definition, but that's like a poor description of what we all know to be true.
But we all know something's true, but we can't say what it is. Like, to me, that's not knowing something is true. That's
just thinking means we don't have a word for it.
No, so let me see if I can. So I'm going to do a couple things here because I think you're getting to something really important. And I was going to bring up falsifiability, and I think Steven is getting at this notion that if you're talking about qualia as an intrinsic experiential phenomenon for which there is no external objective measurement
yet,
but can there be? Because you use the word ineffable. And I'd like to, so I could spend a minute and relay a really important argument in this direction that one of the better philosophers of the 20th century made, Ludwig Wittgenstein, and it's called the beetle in the box. And the notion is essentially exactly what we're getting at. And without reading the entire paragraph, maybe I'll paste it in the Slack. At the end of the day, the idea is it doesn't matter from a linguistic point of view if you and I have entirely different apprehensions of qualia, of experience, of that ineffable phenomenon, because the language we use treats them as the same. And so they could be different, they could be the same, or they could be nothing at all. And our language will never allow us to get at that. And if that is the case, then I do think Steven's point that this notion of the ephemeral, ineffable, what is it like to be a thing, falls in the realm of the non-material. So I'd be happy to take thoughts in that direction, Megan or Steven, but I wanted to point it out as an argument that has been well thought and articulated, and I think it leaves us little room to wiggle about looking for an objective map to an experiential quality.
Yeah, I'll do like about 30 seconds and hand the mic to Megan. I just like to say, in terms of the sort of like, do we use that language? Watching children interact with computers, or having, we talk about computers, like it's tired, it's low in battery, doesn't have energy. Like we actually do use a lot of that language just to talk about our machines. And so like by those criteria, I would say that machines do demonstrate quality, just because in our language, we kind of anthropomorphize them because they demonstrate these properties of consciousness. So.
That's interesting, that because we anthropomorphize something, it has qualia. I don't think that's true.
Well, Megan, if when you kick Steven and he says ow, and you believe it's because he feels pain, you kick the Tesla, you break the headlight, it doesn't scream. But if it did, you might have a different emotional response to that event.
But my emotional response to the Tesla screaming doesn't make it true.
Correct. And I think the main reason we're asking this question today is the point you brought up about understanding which objects in our universe deserve treatment as moral agents and moral patients. A moral agent can be held accountable. Steven, you brought up an example of an autonomous military vehicle acting of its own accord through its own objectives. And I ask, if it breaks the law, is it held accountable? Is its programmer held accountable? Is the general who commanded the lieutenant who programmed it? So let's talk about the morality as it pertains to agency and accountability, both from a legal perspective, but also from a moral perspective, because at some point that Tesla will be a moral patient and probably will be deserving of not being kicked. So whoever wants to go somewhere with that, please feel free.
Well, the obvious answer right now is that no, we don't hold the Tesla accountable. But the argument, I guess, is should we? And I actually, I would like to hear Steven's thoughts on this, because you believe that the Tesla is conscious. So should it be held accountable? Does it have enough agency, or do these autonomous robots have enough agency and consciousness to be held accountable? And if not, why not?
Yeah, I mean, if you look at the way our justice system works, a lot of it is it about justice? Is it about taking people off the street? And I would say if like there's a Tesla that's killing people, like you got to take it off the street. Do we feel the need to punish it? What good does punishment do? I don't know. I'm not really answering the question, but I just, to me, it's not a matter of consciousness or not. That is why we punish or don't punish, or how we treat people. I think the reason our morality is baked the way it is like we're in a society, we're all people together, kind of like a social contract thing going on. Like I don't want to live in a society where I can be killed. I basically, we all have to sort of treat each other as equivalents because we're part of a society together. I think that's why we have ethics and morality, not because people are conscious. That's why we're willing to kill people in other countries or of other tribes and things like that. So I think we believe, and I'm actually getting way out of my expertise here. Like I don't really want to talk about ethics because I'm not, like I'm just not, I don't think I'm that good at it. But yeah, like it's not like when we're going to war against another country and killing them, it's not like they're not conscious. Like we try to emotionally pretend they're not conscious because we're emotionally wired to like, it's easier to kill someone if you dehumanize them, but that's not why we're doing it. It's all about whether you're one of my tribe or not. And so I don't actually think consciousness factors a lot into the morality. I think we think it does, we say it does. That's like a lip service we pay. But when you get down to brass tacks, I think there are a lot of other reasons why we like enforce, why we imprison people and do things like that. And right to life as well. Like it's like, oh, what if I were in a coma? That's a huge part of it. Like, what if I were aborted? So I don't think that consciousness is a meaningful concept in that regard. I think it's kind of an artifact of older ways of thinking. Like that's kind of what I would like to see happen. You know, as we start to realize like consciousness isn't, there's no magical thing. It's a bunch of properties and machines demonstrated, and you know, that's kind of that. Let's move forward.
Megan, do you want to add anything here?
Yeah, I mean, so I think this is intimately connected with the idea that the autonomous drone has agency or free will. It is intimately connected with the idea that such an agent like a Tesla might be able to simulate other minds. And Steven, you also said that you think that some artificial agents now can simulate other human minds better than we can. And I don't think I agree with that either, but even if they could, like, I don't necessarily think that simulating other minds, the ability to run that simulation forward, is synonymous with consciousness. That the idea of free will and agency and choice and intrinsic goals and motivations and desires, that these are intimately related to this idea of, you know, do you take the Tesla off the street if it starts to malfunction because it's a danger to other people, but do you turn it off? Do you kill it? And that's a different question. It's not really about punishment. It's about like, what are the moral consequences of turning it off? And if we do think that even my thermostat or my TI-83 is conscious in some capacity, do I need to worry about turning it off? And where do I draw the line? Where is like conscious enough that I'm allowed to unplug my thermostat or my, you know, take the batteries out of my calculator and not feel bad about it? So I think they are kind of related, even if we get out of the morality kind of stance for a moment, and come back to it more as even some of the other kind of collection of bag of tricks that you pointed out.
Yeah, I mean, we kill animals. I mean, there are probably at least a couple of people on this call who are not, you know, vegetarian. Maybe more like a handful, but you know, like some that it's not like that consciousness criteria. I think most people acknowledge that a pig, they're highly intelligent, problem solving, like they feel pain, you kick them. A cow you kick, like a chicken you kick, you feel it. Like it doesn't stop us from killing them. So I get again back to my sort of ethical position, where it's like, well, like that isn't really that important. It's not really the criteria. It's more similarity to us and whether we can imagine ourselves as us. But I kind of want to maybe move to a slightly different point, which is about like you mentioned simulated minds. And I actually have this kind of curious notion that like a simulation of a machine isn't as conscious as the actual machine, that a hardware implementation is actually important, which is probably curious. People probably don't expect me to say that. I'm the kind of software person. But when I look at those criteria of consciousness, like awareness, like what it means to really know your location in space and know where you are in space, if you have some simulation that tells you that you're somewhere in space, as opposed to actually being there, like having a functional versus dysfunctional GPS, to me, that's actually a pretty meaningful distinction. I think it's something that separates my position from a lot of other like AI consciousness kind of people, in that like the material embodiment is actually pretty important for these kinds of properties I mentioned to be like real and not like kind of simulated. So I think there's a sort of authenticity there to a machine that genuinely knows, you know, like its sensors are actually reporting reliable data about the world as opposed to hallucinations or simulations. So yeah, similarly, like if I were in this thing and I was watching something in virtual reality, like, you know, I had some kind of John Malkovich matrix thing in my brain, I thought I was in Cleveland, you know, would that be a genuine consciousness, like self-awareness? Like I'm aware that I'm in Cleveland, but it's wrong. So somehow I think the hardware matters. I don't know where that fits in, but your sort of, you know, points about simulated minds. I don't know.
No, that's a fascinating topic. We could go a long way there, but I looking at the clock, I'm realizing we're starting to get close to time, and I want to make sure you each have a chance to sort of synthesize some of the conversation and use it to make a closing argument. So I'd say, why don't we give each of you 5 minutes to make your closing argument? And I realize there were a bunch of questions on the Slido that we didn't get to. Perhaps the speakers would be kind enough to share their contact info. If people want to follow up, we could potentially take some of those conversations offline. But in the interest of time, I think it makes sense to turn to the closing statements. We'll go in the same order as the opening statements. So Steven, you'll have 5 minutes to wrap up with any closing thoughts.
Great. Thanks. So before I close, I just like to again thank Dylan, thank Todd, thank Megan for what's been a wonderful event. I'm so stoked to see all the audience questions. I'd like to thank the audience as well for attending and just stimulating to see. You know, I wish we could answer them. Maybe Todd, we could do a lunch or something, a bit of the overflow. But yeah, I just think in terms of, you know, my basic argument, yeah, I haven't really heard much here in terms of a thing that can be demonstrated that machines don't do. So I'm still not finding much reason to kind of waver from my basic position and my basic framework, which is, you know, there's a lot of things within under this umbrella of consciousness. All of the ones we can define are performed by machines. You know, 30, 40 years ago, there are far fewer things under that umbrella. We've added a bunch of things, and machines can do them as well. So all these properties of consciousness are more like things that are needed to be an intelligent agent to make decisions, to navigate, things like that. We see them in machines. And so, yeah, I haven't really heard anything that machines don't do that can be clearly defined or demonstrated in any kind of way. So yeah, I'll close on that. But yeah, just to reiterate my point, like that seems clear evidence that whatever this consciousness thing is, however it could be demonstrated, machines demonstrate, therefore machines are conscious as far as we can define the term.
All right, that seems like a reasonable summary of your position. Megan?
Great. Yeah, this has been really fun. And thanks to Steven for inviting me and to Dylan and Todd for facilitating this. This has really been a pleasure. And I'm definitely happy to follow up also with other people if you guys want to reach out to me via email, or like Twitter is also a great way to do that, so it doesn't get lost in my email box, because I get tons of emails. So please find another venue, and we can do it that way. But so I think I also am not swaying from my position here. I don't think that we have reliable evidence to conclude in any capacity that our current machines are conscious. I don't think that they could not become conscious in the future if they became sufficiently complex or began to exhibit other computations or embody other computations that we believe are involved in the creation of consciousness. So I think it's possible. I just don't think we're there yet. And one of the things that Steven said, I think really sticks out to me is that, you know, to the extent that we keep adding these things that we think are associated with consciousness, or that we think are maybe even synonymous with consciousness, depending on who you ask, and that machines can keep ticking off these boxes one by one, this is not an exhaustive list yet. And I will be the first person to admit that we don't know exactly all of the pieces of the puzzle yet. But given the heterogeneity of the existing theories of consciousness and the plethora of experimental evidence that supports one or the other theory in various capacities and then refutes another one. You know, we mentioned IIT, integrated information theory, and phi, and this measure of complexity. That's one piece of the puzzle that has received a lot of attention in the press, but there are like 50 others. And they all are there because they have experimental evidence supporting them. And we don't know which one is right yet. And some of them suppose or propose even that there are aspects of consciousness that I don't think have been demonstrated in machines yet. So I don't think that machines have a true enough theory of mind or metacognitive capacity or self-referential capacity to count the way that we think of as consciousness. And I think that if this is one of our critical features, the ability to simulate other minds, that a thermostat definitely is not conscious. A photodiode is definitely not conscious. An iPhone can maybe simulate another iPhone, but can it simulate itself? I don't know. So these are like, yes, we are continuing to add horses to the carousel and stuff, but there's a reason that we're doing it. We're not just coming up with these kind of willy-nilly. It's that there is experimental evidence suggesting that our definitions of consciousness are incomplete. And so we need to keep doing that. And so to the extent that, that there are things on the list out there that we know are associated with consciousness that I don't think machines do yet, I don't think that they are conscious. And that's where I will end.
Great. No, that was excellent summary. Thank you so much. And I know sometimes in debates, there's a vote of some sort and a winner, and we're not quite doing it that way. Although I did just add a question to the bottom of the Slido, which is our debate, essentially, are machines conscious? So if any of the viewers out there believe that that statement is true, maybe upvote the question. And if it gets more than 10 votes, I'll say that Steven made a dent in the discussion. Otherwise, we'll have to leave it. Oh, here in Zoom, I wouldn't even know how to begin.
A low bar. I get the low bar. I like it.
I got it. 1 second.
And I came up with the number 10. But wait, Todd might have a poll for us. And then we can give everyone back their evenings. Thank you so much for joining, everyone, for taking part in this fun conversation and listening to these two great speakers debate such an important question. And with that, I'll hand it back to Todd if you'd like to run a poll. Otherwise, thank you, everyone. Oh, here it comes. There's the poll. Let's let everyone vote. Todd, you'll have to tell us.
I'll let you guys know very soon.
We have to keep the Zoom open to get the votes, yeah?
Yeah, and by the way, my Slido question's already up to 8 votes, Steven.
Cool. We've got 33 out of 40 people voting, so 82%, and it's not, keep on going up.
Does anyone need $20 to $50? You know, I'm willing to buy votes.
I know why you're not ethic. You know, you don't really want to talk about ethics, right?
I just need 2 more. Come on.
Yeah. All right. Well, right now, as of right now, it's yes 20 to no 14.
Wow.
20 to 14.
Oh, we should have taken the poll before also. It's seen how many minds were changed, but
right.
Color me surprised.
Yeah. Before and after, right? Next time.
Awesome.
But anyways, thank you all for an amazing debate. Thank you to our audience. But yeah, again, round of applause, right, for Megan, Steven, and Dylan. Thank you all. So anyways, we do events like this all the time. Next week, tomorrow, sorry. We have an event called The New Normal, where we'll be talking about reimagining AI ethics. So Steven, you should definitely drop in. It's at noon. You can go to joinai.la and find out more.
Quick shout out for The New Normal. Everyone, this is an amazing event during COVID times. I've met so many wonderful people. Like it's great networking. I've connected with really smart folks. It's always fun. It takes like 30 minutes. Like you should make it a regular event in your life during these COVIDious times. It's an awesome event, Todd. So
thank you so much, Steven.
Every Thursday at noon.
Thank you. Yeah, it's fun doing them as well. And so yeah, hopefully see you on Thursday, tomorrow on Thursday. If not, maybe next week. But anyways, enjoy the rest of your evening, and we'll see you next time. Thank you all.
Thanks very much.
Great job, guys. Thanks.